Today we are talking about how to write a literature review, what it is, what it isn't, and how you can structure it. And I will also provide a couple of examples for you to follow and to use in your literature review writing, since it's the first major section of any research project. So first, let's establish what a literature review is and isn't. So it is a gap analysis, and it is not a history lesson or a Wikipedia article. What does that mean? So, what's an encyclopedia article, right? It provides you with some basic facts you should know about any subject. Just like a history lesson. So it's just an assortment of random facts or not so random facts, but they are just there for you to learn. But literature review is not like that, or at least it's not supposed to be like that. It is supposed to be an analysis of what's already done and what needs to be done to improve the current state of affairs. That's why we call it gap analysis. So, gap meaning some hole in the knowledge that we have on the subject. So, that's what a literature review is supposed to be. And here is what its main purpose is. So first, you need to establish best practices or state-of-the-art current understanding of the problem. So suppose you are studying high entropy alloys, like right, and maybe high entropy alloy coatings on nickel-based alloy parts. Why not? So first, you need to understand what's already been done on this subject. What other people believe, what they know, what we do at this stage, in this day and age. Next, you should look for conflict. So, for example, you find two articles by two different authors, and one author says that high entropy alloys improve corrosion resistance, but, for example, reduce tensile strength. And the other author says that in reverse, so for example, that high entropy alloy coatings improve strength or plasticity but reduce corrosion. That's just an example. And here is your conflict, right? So the authors have opposing opinions. And that's exactly what we are looking for when we are writing a literature review. So we're looking for any discrepancies, any differences of opinion, conflicts, and everything like that. And that's our gap. So that's where we know that there is something missing in our understanding of how this topic or subject works. And that's exactly where we should focus on our attention. So these are the goals of a literature review. Understanding what's being done right now, understanding whether there are any conflicts, and finding any gaps or holes, missing parts in our knowledge. And that's what a literature review should be. Any questions at this point?
Наче нема.
Okay. And just one extra tip at this point. It's very important to look for the most recent sources and credible sources. We already talked a little about it in one of our previous classes, and I gave you three requirements for finding good sources to use in your works. And those requirements feed directly into the purpose of literature review. So, for example, if you use a book that was published 50 years ago, it's unlikely that it has something on the state-of-the-art techniques or technologies or methods that are used nowadays, because it was published 50 years ago and it had best practices at that time. And they might have changed in this time, and maybe some new methods or technologies were introduced. And if you don't use any recent sources, you are missing out on them. And so your whole work may be just obsolete because someone has already solved the problem that you are trying to solve with a book published 50 years ago. And the same goes for conflict identification. So you can't just trust a random blog post on the internet or any fact or idea an AI generates for you, right? Because, well, if you can't trust the source, how do you know if the information is true? And so you can't actually use it to decide if there is any conflict or any gap in knowledge. That's why it's so important to use good sources. And we've already talked about how to identify them. Okay, moving on. So, suppose you already have your topic, you have your sources. How do you actually write a literature review? I know that most students find it pretty difficult because the first impulse is to just copy and paste information from your articles or books or any other publications and just fiddle around with them to make them look original and slap a few citations there, and it seems like it's a great literature review. But that's not how it works. Especially if you have to write a pretty substantial research project. For example, in your thesis, it will be around 30 pages. So that's a lot of information. And if you, for example, have 5 or 10 sources, just randomly picking paragraphs from those sources and mixing them together to make a literature review doesn't work. That's why we should focus on the outline or the structure for your literature review. There are many ways you can structure them. For example, a chronological review you can use. It's when you describe how things were done, like 100 years ago, 50 years ago, 10 years ago, and now. But I think you understand that it's not really applicable for Foundry technology because we don't really care how it was done 100 years ago, because we just need to produce some good parts we can sell. That's why chronological literature reviews aren't that common in our research field. Instead, I offer you two choices. The first one is the funnel literature review, and the second one is thematic. What's the difference? When we use a funnel literature review, you start with a general broad object. If you remember, we talked about objects and subjects last time. So you start with your general object, and then you gradually focus your literature review on a specific subject, on a specific knowledge gap. So, for example, you can move from general solidification theory to specific dendritic growth in nickel-based superalloys. So you start big with general solidification and then gradually narrow it down. I will provide another example on the next slide. So just wait for it. And a thematic literature review is different because instead of going from the general to the specific, you just break it down into sections by variable or topic or theme, and you focus each section on a specific item, method, or anything else. Here's an example. First section would be the effect of pouring temperature. The second one would be influence of mold material. And the third one, inoculant efficiency. So as you see, each section is devoted to a new topic within your research study. So these are your two options. You can try to mix them, but generally it's a good idea to choose one or the other. So let's look at how a funnel outline works. Here's a funnel, so something broad, then narrower, narrower, and the most specific one. Here's an example. The influence of rare earth additions on the high temperature creep resistance of heat-resistant nickel-based superalloys. That's the topic. So if you want to use a funnel type literature review, you start with fundamentals of solidification and phase stability in nickel, aluminum, chromium systems. So generally, how does solidification and phase stability in these specific alloys works? That's a pretty broad topic. Next, you narrow it down a little and focus on the mechanisms of high temperature creep and grain boundary sliding. So not just phase stability, but the specifics of creep and grain boundary sliding. In the next section, you narrow it down further. The influence of alloying elements on gamma prime microstructure. So now you are not just talking about creep, but you focus your attention on the influence the alloying elements have on this specific type of microstructure. Next, you narrow it down further to the role of rare earth elements such as cerium, lanthanum, and yttrium on superalloy metallurgy. So instead of just all alloying elements, you focus on rare earths elements. And finally, you focus on the impact of yttrium additions on oxide scale adhesion and creep life. And the specific topic you have is optimization of yttrium concentrations for 1150 Celsius degrees service conditions. So from broad and generic to highly specific. That's how funnel outlines work. Hopefully this example helps you understand how you can use it in your own thesis. Any questions?
Зрозуміло.
Okay. And one final note before we move on is that there are no rules on how many of these stages or steps you need to use in your funnel. So there can be 2 or 3 or 5 or 10, depending on your field of study. My only recommendation is that you don't start too generic. So, for example, when someone asks your address, you don't say that you live on planet Earth, right? So you say that you live in Ukraine, in Zaporizhia, or in a specific part of the city, right? And the same principle applies here. So you don't just start with how does molten metal solidify into a solid. You don't start too broad, or you'd have to, well, make your thesis 300 pages long. So even your broadest section should still be specific to your topic. Okay, moving on to thematic type outlines. There are, once again, different ways you can sort them. And one way you can do it is using variable-based outline. So first you identify your independent variables. So these are factors you can change, or at least authors in your sources or your references change. These can be, sorry, inoculant type, alloy composition, heat treatment temperature, mold vibration frequency. So anything you can affect in an experiment. So even if you don't conduct the experiment yourself, you should still identify these independent variables in the sources you look for or in the sources you find. Those are independent variables that you can change directly. Next, you identify the dependent variables. So those are usually the things we actually study or that we actually want to change, but we can't do it directly. For example, we don't just randomly change alloy composition, right? We don't add any super expensive alloying elements just for the fun of it, right? Instead, we want our alloys to be stronger, or we want them to be more ductile, or anything else. And those are our dependent variables. So things we can't affect directly, but that we actually want to change for the better. So these can be mechanical properties. These can be defect numbers like porosity volume or shrinkage defects or anything else. So those are dependent variables. Next, once you have your two batches of independent and dependent variables, you turn your dependent variables into subsection headings and synthesize how different authors used your independent variables to influence them. So, for example, you are researching how to improve tensile strength of a certain alloy. So your section subheading would be improving the tensile strength of some sort of steel. That's your big section. And in there, you look for or you add information from different sources, how authors use heat treatment temperature, alloy composition, inoculation, anything else to affect that tensile strength. So those are your independent variables and they affect your dependent variable of tensile strength. Any questions or comments?
Немає.
So let's look at an example. Here in the table, you'll see authors and years of publication, so your references. Two dependent variables are tensile strength in megapascals and elongation in percentages. And then there are two independent variables, alloy plus inoculator and the process of effecting that or the technological process or different technological parameters affecting those dependent variables. So basically, you can dedicate one of your sections of your literature review to tensile strength and the second one to elongation, or you can combine them in a single section about mechanical properties, for example, and then describe different ways they can be affected. Here's an example of a paragraph that synthesizes all this data into one short passage. So, strategies for enhancing tensile strength. Recent advancements in aluminum silicon alloys demonstrate that while traditional strontium modification yields moderate strength of 240 megapascals, the integration of grain refiners like this one, combined with ultrasonic treatment, can push values towards 280 megapascals. However, the most significant improvements are achieved through microalloying with strontium zirconium combined with T6 heat treatment, yielding peak strength of 310 megapascals, albeit at the cost of reduced ductility. So as you can see, we've taken all of our data points about tensile strength and elongation, as well as our independent variables, and combine them into a single passage. And please notice that there are references to specific publications, so where the data came from. That's what a literature review is all about. So it's not just about repeating what you read in a reference or an article, a book, anywhere else. Instead, it's combining data from different sources to come up with something of your own. So this is how variable-based outlines work. Of course, it's just one small example. If you take a deeper dive into learning anything about tensile strength of aluminum silicon alloys, you'll find plenty more sources, and you can dedicate several pages or even dozens of pages to different ways to affect tensile strength and elongation separately or at the same time. But this is just an example. Any questions or comments?
Поки немає.
Okay. Then let's move on to the synthesis matrix. It works kind of like the previous one, but without the complication of identifying independent and dependent variables. So instead, you create a table using rows to specify specific authors and year of publication, and the columns are your study parameters. So anything you can find. Those can be alloy system, casting method, cooling rate, primary defect, inocculator type, heat treatment temperature, anything else, any parameters you find in the studies you use. And then you just turn all those column headings into your subsection headings and add data from the different sources. So these types of matrices, they make your writing much easier because you already have your general idea of what your subsections should be and which sources have which data. So you can then go there and pull more information from the sources into your work. Let's look at an example. So here is a synthesis matrix for research and porosity in aluminum silicon alloys. So here are authors and years of their publications. As you can see, some are pretty recent and others are quite old. Here are alloy systems and casting methods for ranging from sand casting to high pressure die casting to permanent mold gravity casting and anything else. Here is the cooling rate, kelvins per second. Obviously, high pressure die casting would have the highest cooling rate, while sand casting would have the lowest. And primary defect or finding. So, for example, for sand casting, there would be high hydrogen porosity, coarse eutectic silicon, and other defects. For high pressure die casting, gas entrapment and would be an obvious defect. But at the same time, there would be fine dendritic structure that could alleviate the effect of gas porosity. And finally, for permanent mold die casting, there would be shrinkage porosity controlled by strontium modification. So how do you use this type of metrics for your literature review. Once again, you can use the thematic layout or outline and, for example, focus on the casting method. For instance, you can compare the defects characteristic for this type of alloy, aluminum and silicon alloys, for different casting technologies. So, for example, your first section would be about the defects that occur in these alloys for sand casting. The second section would be for permanent mold casting, and the third section would be about high pressure die casting defects. And finally, as a conclusion to your literature review, you would take the data from these three sections and compare them and, for example, identify the best technological conditions for producing defect-free castings from aluminum silicon alloys. So that's one example. Another approach using this same data could be by structuring your literature review around different types of defects. So, for example, you could focus one section on gas porosity, the next one on shrinkage defects, and the third one on burn-on, for example. And instead of focusing on casting technology, you would focus on defects and explain where they come from, which technology produces them, how you can prevent them. And so, once again, the conclusion to your literature review would be suggesting the best technology or combination of different technological factors that would produce defect-free castings. So, same data, same thematic outline, but different focus and different results. So here's how you do it. Any questions or comments?
Відсутні.
Okay, then just a few more practical suggestions for you. The first one is how to write synthesis paragraphs. You can use the PEER model, PEER. So that's an acronym for point, evidence, explanation, and relevance. So ideally, in a perfect world, your every paragraph or passage would have these four elements. So first, you start with making your point. So state the consensus. So something that all the authors you've studied agree on. Or alternatively, start with a conflict. So something different authors don't agree on. That should be at the beginning of your paragraph. Next, provide evidence. So first you just generally provide your point. Next, use your sources to provide specific data from your studies. So for example, you say that the authors don't agree on something. The first, that's your point. Your evidence would be that the first author believes X and the second one believes Y. That's your evidence. Next, you provide an explanation. So that's your idea of why their results differ or why they all agree on the same thing. So that's where you come in. So you only use source data and then you provide your explanation. How do you understand it? Why that happens? And finally, finish up your paragraph with relevance. So bring back your explanation and this whole topic of this passage to your research goal. So why does it all matter to your research topic, to your subject, to your research question? So these are the 4 elements. Let's look at an example to see how it all works. So here is an example of a peer model paragraph. It's about the impact of cooling rate on a nodule count in thin-walled ductile iron. So we start with a point. A critical challenge in the production of thin-walled ductile iron castings is the inverse relationship between the cooling rate and the nodule count, which directly dictates the final mechanical properties of the part. So here we provide a general statement about our research topic. Next, we provide evidence from different sources. According to Lebrecht, increasing the cooling rate in 2 mm thin wall sections can lead to a significant increase in nodule count, often exceeding 2,000 nodules per square millimeter. However, Stefanescu observed that while high nodule counts are achievable, they are frequently accompanied by carbide chilling if the inoculation practice is not precisely adjusted for the accelerated solidification. So here we provide evidence from 2 different studies showing that there is some discrepancy or some conflict between findings. Or rather, it's not a conflict, they seemingly agree on the same idea, but the second author provides more detail and specifies that there are some issues with this general idea. Next, we provide an explanation. The discrepancy arises because the high undercooling associated with thin section casting promotes a high nucleation frequency, leading to more nodules, but simultaneously produces the solidification path into the metastable system, where cementite becomes the preferred phase over graphite. So, here we explain the difference of opinions between the 2 authors we've cited before. And finally, we explain why it all matters. So, relevance. As my research aims to optimize the casting parameters for automotive suspension components with varying wall thickness, understanding this threshold between beneficial grain refinement and detrimental carbide formation is essential for designing a robust inoculation strategy. So here you tie it all back together to your specific topic or to the goal of your study. Of course, you don't have to be so specific about how the data from the sources affects your specific research question, but still you should always keep your main research question in mind. And if you notice that the data you add to your literature review doesn't actually have anything to do with the research topic, then maybe you don't need this information and you can just delete it from your literature review, even if it pains you because you need to achieve your page count. So here is an example. Hopefully it helps you better understand the idea of this peer model, but if you have any questions, please voice them. If not, then let's finish up with a few more practical tips. So, in my experience, many students struggle with keeping to a technical tone or voice, and some use tenses all over the place. So, how do you keep your writing consistent? If you describe specific experiments or specific results of the researcher's findings, you can use past tense. So Zhu et al. Utilized a copper chill to achieve a cooling rate of 50 Kelvin per second. So utilized, that's your past tense. If you are just describing some established laws, some established practices, or accepted opinions, you can use the present tense. For example, increased cooling rates generally result in a refinement of the eutectic silicon phase. So as you can see, this sentence is written in present tense. These rules apply to your English writing and your Ukrainian writing as well. So please pay attention to your tenses and only use future tense if you describe, for example, future potential for future implementation of your findings or your plans for your future research. Even if you are writing, for example, a methodology section, you don't have to write that we will use an induction furnace to melt our aluminum alloy. That's not necessary, considering in most cases you would write methodology after already completing your research. You can write it in past tense, so describing that something that has already happened. And finally, for a long time, passive voice was standard in scientific writing. But in the past, like several decades, we have moved on to active voice. So where possible, you can use active voice, especially when attributing ideas. So you can write that Smith argues for X, but this study adopts the framework of Jones. So you don't have to write something like the study was conducted by Smith. That would be passive voice, and it makes your writing harder to understand. So using active voice where possible is a good idea, and if you use any spell checker, they will usually highlight passive voice as something you should avoid. So these are just technical tips for improving your writing. And a few more ideas how to make writing your literature review a bit easier and better. So first, use digital bookmarks or highlighters. That's very useful, and many students still ignore it because it feels like a waste of time at first. So when you are reading your sources, instead of just underlining your some important ideas or just copying and pasting something into a separate file, at the reading stage, start dividing or splitting the information you find into batches. So if you're using highlighters, use, for example, red for gaps, knowledge gaps and problems, green for methodology, and blue for numerical results, so quantitative study results. If you don't use digital highlighters, you can just copy and paste information from the source, but for example, create a table for use rows for different sources, and one column would use gaps problems, the second one would be for methodology, and the third one would be for quantitative results. These will help you remember which source the information came from, and it will also speed up how you structure and write your literature review, because as you've seen today, synthesizing new information takes effort, and having all the information you can assess at a glance will help you a lot. Next, ideally, once again, in a perfect world, every paragraph and every section you write should have at least 2 citations. If not, if you only cite one source per paragraph or per section, that's not your work. It's just a summary or a paraphrasing of another's work. And that's not what you are here to do. So, your thesis, your literature reviews should synthesize data from different sources. So, 2 citations per paragraph or per section at least. Next, using transitions to start your paragraphs or to tie different paragraphs together is always a plus. So don't just start with a statement. Instead, lead with agreement, contradiction, or refinement. For example, if your new point aligns with the previous one, you can start with something like in alignment with these results and something else. If your new point contradicts the previous one, you can start with conversely or on the other hand or alternatively, something like that. And finally, you can refine or add specific information to the previous point. So, building upon or further researching this idea or this method, something like that. So, this helps tie different ideas together, especially if you use lots of sources and just slapping information together, it can feel just too disjointed, too messy. And transitions help you better understand how all this information ties together. And the final practical tip is to use a reverse outline. For example, once you've finished one section of your literature review, or even one page, write a one-sentence summary for each paragraph. If 2 consecutive paragraphs have the same summary, they are redundant. So you can remove one of them or at least combine them into one. So, I know it can be tempting to divide your work into lots of tiny, small paragraphs and write all the same things in them just to hit your page count. But still, every paragraph should hold one major idea. And if you have anything to add to it, just make your paragraph longer instead of just splitting it up. And even if you, for example, have finished it but remembered something later, go back to that paragraph and add to it instead of creating a separate section or a separate paragraph. This will help keep your writing more logical and more organized. Any questions or comments?
Наче немає.
Okay. And let's wrap it up with a quick summary. So, just a reminder that a literature review is not a Wikipedia article. In instead of just stating facts, use your literature review to identify knowledge gaps and justify your study. When writing your literature review, you can choose between a thematic and a funnel outline. We've covered both, so you have a rough idea of what they are, and you can choose whichever works best for your topic, or you can even make a choice based on the sources you found. Finally, remember that even if you are only writing a literature review for your thesis, it's not just a summary or a paraphrasing exercise. Your job is to analyze and synthesize data based on what you read. So instead of just paraphrasing or even worse, copying and pasting data from the sources, use the point, evidence, explanation, and relevance model to ensure you synthesize instead of summarizing. Okay, that's all from me for today. Any questions?